Hello and welcome to my Blender to Unity Tower Defense game tutorial, and in this part we're going to be getting this little fella here going from left to right and running along the path here. As you can see, it's following the route and it's doing a little bit of rotation to point in the right direction. So without further ado, let's get started. Before I get into the meat of this, one thing I did do, by the way, was I changed the directional light. I actually reset it to be, I think what I did was I just clicked reset here and I moved it up a chunk. Whatever, it doesn't really matter on directional lights. Ooh. Sorry, do that again. We'll just set that to something like 15, but the point being that I set this to 90 degrees. Okay, so it's pointing straight down. That'll make sure that the shadow shows directly over the path. I found it slightly confusing when it wasn't over the path. It was hard to know whereabouts it was, so I think that makes sense to have the shadow pointing straight down. Okay, now then, the way that the tower defense paths are usually designed is such that what you would do is you would set up a bunch of positions that the alien or the game object would move along, and we will do that now. The best bet is to simply use what's called an empty. All game objects in Unity have a transform, so it's this piece here that contains its position and location and what have you. So let's quickly get started with that. If we just right click over here and say create empty, and that will say game object, we'll drag that out of directional light, and if we just spin and click the Y icon here, if it isn't set to orthographic, I don't know how easily you can see that, hang on. It's perspective now, so let's just set that again so it's not difficult, easy to see, is it? But ISO, there you go. Okay, and we'll just make sure that that's. Just click on that again. There we go. So we're dead straight down the top. Okay, and what we can do is we can just what I started with on this first one was just positioning in this piece here, that corner there, and then just dragging that over to the left, just outside where the those quads are that hide the holes that we created. And now what we can do is click Control D, and that will create a copy of that same empty, and we're going to drag that across to that corner there. And then it's just a case of clicking Control D and dragging to the center. You'll notice that I haven't got it quite right on the center points, but that's okay. Control D and then drag this along. Control D, drag this along. Like about there maybe. Control D. I'm not thrilled with this path, by the way, so you can always create multiple ones. As you know, we made that quite easy to do in Substance Painter by having a specific layer that contained the path, so you can go back in and change this if you want to. I hope this is making sense. I'm just hitting Control D and just dragging it around to the next point, and I'm not adjusting the height. They're all set at interesting height 15. Okay, so we might need to change all those, but let's quickly just finish off. Control D and then just drag that over there. Okay, how are we doing? Yeah, they're all much too high. They've all got a height of 15. So the best way to get rid of that, to sort that problem out, is just select them all, click on this one here, and just set 0. Okay, and that'll move them all to the 0 position. Okay. Now this is great, but it's a bit messy. So what we'll actually do, what I'll do as well, by the way, is I'll just rename that to game object 0. Okay, because we're going to be creating an array, and the first element of an array is the 0th element. Okay, so it's worth bearing in mind. And let's create one more empty, drag it out of game object, just press F2 and we'll call it path, and then just select that lot and just drag it into path like so. Okay, so then we can just hide that. Great, so we've got ourselves a path. Actually, before we do it, let's just go back to the top view and just go through it, make sure that we've captured all the points. I am known to not forget to press Control D, but that looks good. Okay. Great. Now we need something that's going to move along those paths, so it's time to create a script. By the way, you may notice I've got this completed folder here. That's my guide. Please don't use that just yet. I'm just using that so that we for speed, so that you don't have to, so I don't have to second guess and mess around in this tutorial. So let's create our own one for the scripts. If we click on the assets here and click create folder, and we'll call that scripts. Bear with me, just make sure. If we click on it, Unity's not happy if you have a script with the same name, even if it's in a different folder. So I'm going to create a new C# script, and we'll call this enemy path route. Yeah, that's fine. That's fine. Okay. And if we just double click this, this will take us into MonoDevelop. You may have Visual Studio. I do actually have Visual Studio, but I thought I'd use MonoDevelop because that's the most. I think that's the in quotes free one that comes with Unity. So that's the one we'll use today. So if we're going to, what we're going to do is we're going to create a script here that we're going to attach to a game object, as it would be an alien disk or whatever, and that's going to move it along. So let's set up a few public variables. We'll start with public transform, and by putting the square brackets there, that means that it's actually going to be an array path. Okay, if you weren't sure what transform was, let's just quickly spin back over here. All game objects have this transform. I don't think you can remove it. You cannot. You cannot remove that one. You can remove other components, as you see. Let's just add a input field or something like that, and you can click on here and do remove component. But you can't remove the transform. So all game objects have a transform. Okay, what we'll have as well is we'll have move speed, I think we'll call it. And we'll set that just to 1F. And that what I take that to mean is 1 Unity unit per second. Okay, this is a good start. So now what we'll do is we will spin back to Unity, and let's just close that down. And let's grab one of our prefabs here. Let's grab the alien disk and just drag that in. And we'll set this to -90. I think that doesn't make any difference if you set that. I think later on it'll set it back to -89.9. It's very frustrating. Okay, so we've got our alien disk here, and what we can do now is if we just grab our script, we can drag that onto the alien disk like so. And here you go. You see it's actually created. It's popped the script down for here, and because those variables are public, they're actually visible in the Unity inspector. So these public values here are here, and that gives us the ability to actually change them either while we're debugging it, or while it's not running. And if you change them while it's not running, then they will stay like that when you run them next time. But if you change them while it's running, it will reset back to what it was beforehand. Okay. Now there's a path here. This is actually an array, but there's nothing in it. So what we can do is we can grab these game objects and drag them into that script. But you can see there's a problem. I've lost the script because I clicked on them. So you may recall what I did last time was just click on the lock icon here, and now when we select this lot, that alien disk still remains selected. Okay, and we can just drag that over the word path there, and that puts our transforms in there. Okay, so now we've got a script, but it's not going to do anything. It's got its variable set up, but it's not going to do anything. So what we can do is spin back into the script here and put something in the start here. So let's start. Oh, what we should do is add a couple more variables. We'll say private int current target index, and we'll set that to 0. Okay, so this is where it's going to be heading towards, and we'll also have a private bool reached end target. Okay, and we'll set that to false by default. Okay, and now my intention is that we would go down here and we'd say if brackets not reached end target. I definitely pressed squiggle there, did I not? Okay, I have now. And then we'll do the logic in there. So it's not going to do anything unless that's set to true. Okay, doing that, this may be overkill because if we destroy the game object, it's not going to call update anymore. But I just like to do that just as a catch-all to make sure it doesn't blow up. We'll come back to that. In the start tool, what we'll do is we'll say transform dot position. Okay, so that's this game. That's the transform for this game object that it's attached to. Equals path dot. This is what I don't like about MonoDevelop. Path. Stop it. Path. I'll tell you what we'll do. We'll do path like that. Maybe that'll current target index. Yeah, it's being a pain. Let me quickly go back here and just manually type path, and then just there we go. Path current target index dot position. Okay, now let's press Control S. If we quickly spin back to Unity, let's just see some errors. Parsing error. Okay, so what have I done wrong here? I've probably missed a semicolon or something, have I? This is possibly why I was throwing those errors. Let's just try game object. Let's Control X that. This must mean I've done something wrong up here. Ah, look at that. That's where that squiggly bracket went. My apologies. I'm sure all of you saw that. So let's try again. That's why it was throwing. Equals. Let's try again. Path. Current target index dot position. and we'll say current target index plus plus. Okay, so what that's going to do is that's going to say, right, when you start off, please move you to the 0th element, and your target is the next one, the first element, or element 1, I should say. That's actually the second element, element 1. Okay, so now if we run this over now, what I'm expecting to happen is you to go away. Let's just quickly do clear. Parsing error still. Did I save it? I bet I didn't save it. There we go. Variable EPF is assigned but never used. Where's EPF? That's a different script. That's one I was working on earlier on for the camera. We'll do that in a later tutorial. Okay, let's run this then. Let's run this. All I'm expecting to see now is for our alien disk, which is at 0, 0, 0 here, to move to that 0 element there. Okay. Look at this. This is what I do all the time. You need to click the unlock. I was just thinking, why is that 0, 0, 0? Now we can click here and so on. Okay, I think that for me the path is in the wrong place. Can you see the path has been set to minus 11.27? Bit of a catch. It doesn't make a huge difference. I'm gonna make it right anyway. Let's create another one and just call that. So let's just reset it. Reset its position. Okay, grab this lot, drag it in, and then I'm going to delete this one and rename that to path. Okay, and now that's better. That's better. It was weird that game object 0 was 0, 0, 0. These values here are relative to that value. Okay, and that make no sense at all. I hope it does make some sense. But what it's saying is wherever this position is, if you move these objects, it will be relative to the parent, which is great because you can move everything along left or right, or up or down or whatever. Okay, so let's just click play now. Click on alien disk, which is at 0, 0, 0. I'm very much hoping it'll be something like minus. Let's do that again and turn off maximize on play. And sure enough, the alien disk has gone to minus 11.27. Good stuff, but it's not doing anything. So you can see it's just sat there because what we need to do now is in the update method get it moving towards the place. Let's do that right now. We're going to say transform dot position equals vector 3, okay, dot move towards. There we go. It's a good method. It takes two values, the current position and the target position, and a speed of how much you want to move along it. So let's do that. So we've got the current position, which is our position of this game object, and the path current target index dot position, and then we want that move speed. Okay, but this won't work out of the box. You need to take time times time dot delta time, and what that's doing. Did I see delta time there as well? No, it's lowercase delta time. There we go. What that's saying, time dot delta time, is basically the more frames per second you get, the lower that value. So if it's 50 frames per second, then that value would be 0.02. And if it was a much higher value, say 100 frames per second, it would be 0.01. And what that effectively says is, you know, if you've got a computer with a higher frame rate, it's going to be smoothed out and compensated for, so you don't need to panic about the fact that one computer is slower than the other. It's not a perfect science. I think there is a little bit of wiggle room, but you should expect to see this consistently moving at, in our case, 1 Unity unit per second. Okay, so let's now go back here. By the way, this script won't overshoot. Okay, it'll always hit the target and then stay there. So let's now click on play now, and I'm hoping, and there it is. You can see it moving along. Wonderful. And what's going to happen? I think it's pretty obvious as it's too low. Is it's going to hit there and it's going to stop because it doesn't know what to do next. But let's quickly fix one problem. That path was too low, wasn't it? Let's set the path to 0. If we set the path value in 0.5. Like I say, all of these now, they'll still show a Y value of 0, but actually they've all been moved up to 0.5 because the parent has. So let's now try it again. That looks better. It's a little low maybe. I think we're getting away with it. Good. Okay. Stop that there. Now, we've got our restart target. Wonderful. But now what do? We need to keep moving along. So let's do this. Let's say this. Let's say float distance to target equals vector 3 dot distance between transform dot position path current target index dot position, and that will return a value. Okay, in Blender, in Unity units, I always keep saying Blender units. I do, excuse me. So used to using Blender in Unity units. So they are. I consider them to be one and the same thing. One Blender unit is one Unity unit. Okay, so that's going to show us a distance, which is great and everything. But I think we need to say if brackets distance to target is less than, let's say 0.05. current target index plus plus. Okay, I might even put a debug log there. Let's just say debug.log reached target plus current target index. Okay. Now if we run that, let's go to the console over here. It's moving. There we go, we can see that it's doing the thing here. It's actually moving along nicely. Now the more astute of you will probably notice that when it reaches the final target, it's going to hit a problem, because it's going to say, oh, I've reached the final element. It should say that any second, and it's going to try and go for an index in that array that doesn't exist. So the best way we're going to fix that is now say something along the lines of here, if brackets current target index is the same as path dot length enemy success, or something like that. That's a method, and let's just put that down here. Void enemy success. This should be in capitals, shouldn't it? I'm trying to keep things consistent for the different languages. I'm come from a Java background, so okay, avoid enemy success, and then we'll say debug.log reached destination haha. We will then say reached end target equals true. Destroy game object. That's the reference to this game object. Okay, so now if I'll just put Control S. So now if we run it, here she goes. Maybe I should up the speed of it. I'll click alien disk and set that to 2, maybe. Twice as fast. Okay, just go to the console. 8, 9, 10. There we go, and you'll notice it disappears. It disappears here, and that's because we did that game object.destroy. It doesn't destroy from the main world after we close the script down. It just destroys it in the kind of like in the runtime, which is exactly what we want. I'm really pleased with the way that's working. That seems to work nicely. The one thing you may have noticed is that it's not pointing in the right direction. It's always pointing down. I created this little window here to illustrate the point. We may get away with it with the other craft because it doesn't really have a direction, but obviously most things want to face forward. Now we're going to hit a problem. Let's just go to the script, and what we'll quickly do is we will say, what I'll do is I'll grab the code from my other script that I created earlier. 1 second. Okay, so we'll put it here, and I'll just copy and paste that in. Okay, what I've said here, let's just talk this through line by line. Direction. Okay, this is rather a cool thing about Vector 3s and the way that I guess .NET works, is that you can subtract two objects from each other, and it will return the corrected values. So we've got to put a position that we want to point towards and the transform.position, and that will return us a direction that we need to face. Okay, this may look familiar, this piece here, this move speed dot times delta time. It's very similar to this. Excuse me, I got distracted there. The postman just knocked on the door. So where was I? Yes, so this move speed here times delta time. We're going to do a very similar thing to move towards, but this is going to be rotate towards. Okay, we're going to send a direction that we want to face and the target direction that we want to face. Okay, so basically what's forward for us right now? Where do we want to be forward? How fast do we want to go? And this value here is just a default value. I think, as far as I'm aware, I've always set that to 0f. Okay, and then we can set our transform.rotation. And then we get the dreaded quaternions. Now, I don't know particularly a great deal about quaternions, only other to say there are plenty of useful methods in there that are going to do things for us. So we can set our transform's rotation value to the quaternion.look direction. Okay, and that kind of converts it to a quaternion direction, which is a 4 value array, I guess you'd call it, which is much more complicated but also very, very fast, which is why they like to use quaternions. So let's run this and have a look. I'll just press Control S. Excuse me, Unity, where are you? There you are. Let's press play and see what happens. I know exactly what's going to happen because I ran this earlier on. It's going to be not rotating at all. Ah, interesting. It's actually doing some very, very weird rotation. You see that? It's kind of flicking. Okay, let's have a little look at why that might be the case. We've said path minus transform. We've set the step. Transform.rotation is look direction. Look, new direction. Ah, I think I know why. We put it in completely the wrong place. Oh dear, happy days. Sorry about that. There we go. Sorry for those that spotted it. We don't want it every time. We don't want it when it's changed. There we go. There we go. Now so Control S. Press play again. There we go. Now I'm expecting a slightly different result. There we go. It's facing the wrong direction, and the reason for that, as you may recall, is because we're actually rotating our FBXs by 90 degrees when we start, and this is counteracting that and setting it in the right place. It's been a problem that I've been trying to figure out in the easiest way possible, and I have not come to any real clean conclusions other than the best way to do this is to do the following, and that is create a game object, create empty, excuse me, and we can call it alien disk again, I think, and we'll drag this alien disk object into the empty. Okay, let's just make sure we reset all those values and set that to -90 there. Okay. No, actually, let me take it out of that thing first and then I'll do it. Reset and then set that to -90. I'm also going to make sure this empty is also reset, and now I'll drag it in. I like just to keep everything as clean as possible. Okay, there we go. So now we've got our alien disk. Okay, now this alien disk empty is all reset, so forward is correct for it, if you like, might be the right term. And what we can do is we can get the script now. We won't apply it to this alien disk, we'll apply it to the empty that contains the alien disk, if that makes sense. So if we just click on here, what we can do is we can actually say copy component, and if we go over to our alien disk empty and then click on here and say paste component as new, it'll copy that script in and the value. So we can go back to this one, back to the alien disk, and then just grab that script and say remove component. Let's see how that looks. Here we go, moment of truth. Okay, is it rotating towards the objects? It is, albeit facing the wrong way. Now what we can do, if we just pause it and we'll click on the alien disk, the underlying, what we can probably do is just try some of these rotations and see which one fixes it. I'm adjusting the Y and that looks to be the right one. So it looks like I might have to set the Y to 180 degrees. Let's just try it. Okay, and now we'll just press play. Notice that it was the alien disk object, not the alien disk empty. Okay. There we go, that looks to be facing the right way. Fabulous. The other thing I don't like about this is it seems to only start, well, it does only start turning once it's reached its destination. It would be kind of cool, would it not, if it started turning a little bit early, just to give it a little bit more realism. Yeah, you see. Okay, if it turned a little bit earlier, it would look a little bit cleaner, wouldn't it? So let's have a little look at the script and see what we can do. If we go over here, we could say something along the lines of, so int target to look at index equals current target index. Okay, and then we'll say if brackets distance to target is less than 1, let's say 1, yeah, okay, that's a bit of a guess, then target to look at index equals current target index plus 1. And then we'll change this down here to target to look at index. Does that make sense? Can you see what I'm doing here? So I'm saying, you know, by default, it's going to look at the current target index, which makes sense. But if you're actually getting quite close to the to that target, actually look at the next one. Okay, so let's just give it a play, see how that pans out. Save it. See how we're looking. It's coming out. It starts to turn. That looks good. But I can tell you, we're going to hit a problem. If we just go down here, I am very confident that when it reaches the final one, as in now, it's going to approach that end target and it's going to get close and it's going to try and look at an empty that doesn't exist. Am I right? Yeah, there we go. Can you see it's blowing an array indexes out of bounds? Okay. So if we spin back over here, I think what we probably need to say is if distance to target is less than 1 and current target index is less than path.length. Okay, so it's less than path.length. Let's give that a try. If we quickly spin on here and just change it to 2, make our life a bit quicker. It'll approach that last one and failure. Okay, I think the reason for that is because it probably needs to be path.length minus 1. Let's put that in brackets to be absolutely clear. So we're saying here, if the distance to target is less than 1 and the current target index, as in the current one we're pointing at, is less than the path length minus 1, then you can look at the next one. Otherwise, just keep on the current one. That seems to be reasonable to me. Let's see if that works. I come back in. If you press play too quickly, it doesn't seem to work, which is slightly confusing. Let's set that to 2 again. Go to the console. We're expecting that alien disk to disappear at the end. Boom, done it. There we go, guys. We have an alien, a path script that will take us along an array of transforms, and when it gets to the end, it will destroy itself. I mean, we probably want to add some stuff here to say, you know, apply damage or something like that, so that obviously there's more of a game of it. It doesn't just disappear, and you know, there's no point to it. But we can work on that. That I'm going to call a done job, I think, for this episode or this tutorial. Thank you for watching. I think in the next one what we'll do is we will work on creating more of a wave, because at the moment you'll notice that I've got this thing in here. What I'll probably do is have some scene script that instantiates these and then moves them along from one point to the next. Obviously you never have one on its own, certainly not in later waves, tower defense waves, so we'll work on creating a script that does that. But for now I'm really happy with the way that works. Thank you everyone for watching. I look forward to seeing you next time. Please like and subscribe. I love those likes and subscribes, and if you've got any questions, please put them in the comments. I will do my utmost to respond to you as soon as possible. Thanks again. See you next time. Bye bye.